Okay, in lesson 39, we're going to cover equivalent equations and the addition-subtraction rule for equations. Now, thankfully, the equivalent equations part is super easy. So let's go and start with that. Look at these three problems. Actually, I'm going to do it up here. Now remember, anything that has an equal sign is an equation. Alright, so these are all fairly simple equations. X equals 6, x plus 3 is 9, and x divided by 3 equals 2. But what's similar about all three of the equations is that x equals 6, as the first equation literally tells us. But notice that in this problem, this middle problem right here, x plus 3 equals 9. X is also equal to 6 because 6 plus 3 equals 9. Also in this equation, x divided by 3 equals 2. X is also equal to 6 because 6 divided by 3 equals 2. So these are called equivalent equations. This means that they are equations, they have these equal signs, and they all happen to have the same answer, where x equals 6 in all of the problems. So that's just kind of a vocabulary term for you to remember, and like I said, hopefully that's not too difficult. Now let's jump into the second part of our lesson, and this is the addition-subtraction rule for equations. You can actually read it on page 127. It's in a nice little box. It says 1 has 2 points. 1, the same number can be added to both sides of an equation without changing the solution to the equation. And the second part, the same number can be subtracted from both sides of an equation without changing the solution to the equation. So the first part of the rule has to do with addition. The second half of the rule has to do with subtraction. Let's go ahead and test this out. Let's come up with a very simple equation like x plus 2 equals 7. I don't know if I've mentioned this before, but I like to make my 7s look like that, because if you just make a 7 look like that, sometimes that could kind of look like a 2 or a 1, but if you go like this, then you know for sure it's a 7. And then sometimes for zeros, I also make a diagonal line through it. That way you don't think it's a zero, an O or something. You know for sure it's a 0. So that's just a random tip. But back to our little equation we made up, x plus 2 equals 7. Now hopefully you know in your head, I think x equals 5, because 5 plus 2 equals 7. So how about I make a little thought bubble up here. And we say, we kind of think x equals 5. But now let's go ahead and test this addition-subtraction rule to see if adding something to both sides of the equation or subtracting something from both sides of the equation will mess up this equation. For instance, let's go ahead and add, how about a 3 to both sides? So we have 3 on this side and 3 on this side. Don't forget to do it to both sides, because if you only do it to one side of the equation, then you will for sure throw it off. So now we have 3 plus x plus 2 equals 7 plus 3. Let's go ahead and simplify a little bit. We know 3 plus 2 is 5. And then we still have that plus x on this side. And then on our right side, we have 7 plus 3, and we know what that equals, 10. So now we have an equation that looks a lot different, 5 plus x equals 10, but can you kind of think in your head, what would x equal in this equation? Well, hopefully you said 5, because 5 plus 5 equals 10. So notice that we came up with the same answer, even though our problem looked a lot different. We used to have x plus 2 equals 7, and that gave us the answer x equals 5. And then we added 3 to both sides of that equation, and we also came up with x equals 5. This is because of the addition-subtraction rule for equations. You can do almost anything you want as long as you do it to both sides of that equation. Let's go ahead and try it again. I'll copy down our original equation. Now let's go ahead and subtract something from both sides. How about let's be really dramatic. Let's do minus 10. I'm going to have to squeeze this in right here. All right, so now we have x plus 2 minus 10 equals 7 minus 10. And you might think, ooh, this is different. We're going to have to go into negative numbers because 2 minus 10 is negative 8. So now on the left side we have x minus 8. And on the right side we have 7 minus 10. Can you figure that out? 7 minus 10 is negative 3. Okay, now we have a much different problem. We have x minus 8 equals negative 3. So in this problem, what would x equal? Now I know this takes a lot more thinking, so let me give you a little hint. Do you suppose that even though the problem looks different, that x would still equal 5? Well, let's go ahead and find out. What is 5 minus 8? 5 minus 8 is negative 3. So even in this problem, which looks crazy different from our original problem, the answer would still be x equals 5. So you'll notice that all three of these equations have the same answer, even though they look very different. Just like we learned about here, equivalent equations and equivalent equations. So that is the addition subtraction rule, and this is very, very, very critical to learning the rest of the book. If you don't understand this, then the rest of algebra pretty much isn't going to make sense. So if you have any questions about this, please let me know right away. And remember, the rule, the addition subtraction rule, is that you can add something or subtract something to both sides of an equation without changing the solution. And we will have to do this a lot as we try to solve more and more advanced algebra equations.